Hello and welcome back. Today we're going to be doing some graphing. So if you'd like, grab yourself some colored pencils or highlighters because we're going to make some really nice looking graphs. We're going to be graphing a lot of curves, so be aware, but that's okay. Just make sure you have maybe an eraser handy or something like that. Now, if you cannot print the assignment, which is completely fine, you need to take some care in drawing the graph. Use a straight edge, whether it's your ID badge, an edge of a piece of paper, whatever. You don't need to draw every little, like all the grid marks. Draw the X and the Y axis and then label the X and the Y axis carefully, okay? Give yourself a lot of room. Don't just kind of squeeze it in somewhere, all right? If you can print something out, you have the ability, please do so, at least just for this lesson. We are going to be graphing some things that maybe look like this, or like this, or like this, or like that. So get ready and let's get started. All right, now in order to graph this, I'm going to show you how to do it without the calculator. I will eventually show you how to do it on the calculator, and if that way is easier to you, then that's what you're going to do. However, you do need to know how to do it without the calculator because sometimes it won't do everything that you need to do. So I am going to start with the cosine. All right, so I'm only talking about the cosine. And I like to start at 0, actually. So, what it wants me to do to fill in this chart is at 0, what is my cosine of 0, right? So you're going to have to, the easiest thing to do is to refer to your unit circle. Remember this nice little thingy here, right? I'm going to refer to it, but I'm going to put it away because I want you to look at your own. So, what is my cosine of 0 degrees? Well, it's 1. What is my cosine of pi over 2? Well, you can look at your unit circle, but I like to convert these to degrees just because I don't know, I just am more comfortable with degrees. So that's 90 degrees. So what's your cosine there? It's 0. Pi, you should know without thinking about that, is 180 degrees. What is your cosine there? -1. 3 pi over 2 is 270 degrees. What's your cosine there? It's 0. And then 2 pi, which is 360 degrees, or all the way back to 0, so it should match the 0, your cosine is 1. 1, 0, -1, 0, 1. If I were to keep going, what do you think the next thing would be? That's right, it should be 0. It's going to follow a pattern. Now I'm going to go backwards here. So let me just draw this little sketch real quick. If I'm going backwards, this is -90 degrees. -180, -270, -360. So if I'm at -90 degrees, that's this right here, what is my cosine there? It's it's 0. -180 is the same as +180. Right now I'm here, and it's -1. -3 pi over 2 is 270. What's my cosine there, or my x value there? It's 0. -2 pi is the same as -360, or 0 degrees, and it is 1 there. So just a reminder, I'm getting all of this information from my unit circle. If you have them memorized, really, you shouldn't even be looking at it, and that's really where you should be at. Now, I am going to graph these. Please notice that the x-axis is already labeled for you, and I don't know why it's cut off, but it matches exactly what I have up on top. So this is pi over 2 pi, 3 pi over 2, and 2 pi. Same thing backwards, it's over 2, negative pi, negative 3 pi over 2. And your calculator will do this for you, and I'll show you when we get to it. Now, as far as the y-axis, if you look up at what we graphed there, the highest we have is 1, the lowest we have is negative 1. So I'm going to have this be 1 right there and negative 1 right there. There's times when we're going to need halves, quarters, etc. All right. So all I'm going to do now is plot each spot there. So I like to start at my 0. So this is the point 0, 1. So I'm going to put a dot there. At 90, or pi over 2, I'm at 0, which is there. At pi, I'm at negative 1, which is there. At 3 pi over 2, I'm at 0. And at 2 pi, I'm at 1. I'm going to go into the negatives in a second, but I am going to try and connect this. Now, this is where it starts to take practice. I strongly suggest you use a pencil. And you have to have a nice curve here. Let's see how I do my first time around. Of course, you're not going to know that's my first time around. It's really my third, but I get to delete it as I go along. And that is one full cosine curve. Can you hear my kids crying in the background? So that's one full curve. It starts up at 1, it ends at 1. That's one full cycle. But I am going to go back into the negatives. So at negative pi over 2, I have 0, and if you notice, it's just the pattern's going to keep repeating itself. If I were to extend my x-axis in both directions, you would just see this curve repeating over and over again. I'm now going to work on the sine. I'm using the same exact angles, except now instead of grabbing the x value, I'm going to grab the y value. Again, I like to start at 0. So what is my sine at 0 degrees? It is 0. Again, refer to your unit circle if you need to, but I'm here and my y value there is 0. Now I'm going to go to 90 degrees. What's my y value there? It's 1. And then I go to 180. My y value there is 0. Notice a pattern emerging here. This is negative 1. And when I go all the way back around to 2 pi or 360 degrees, my y value there is 0. Notice a pattern. It's almost the opposite of what it is. So I'm going to graph that. So I'm going to graph, you got to be careful here. You're going to look here and here. So I'm graphing 0, 0. Then I'm graphing pi over 2, 1. And then graphing pi 0, 3 pi over 2, negative 1, and then back to 0 with the 2 pi. Okay, now when I go into the negatives, I should get, when I'm at negative 90, so I'm going this way to my negatives, my y value there is negative 1. When I go back to negative 180, it's 0. Notice the pattern, and I'm going to connect. And voila. So notice that the curves look very similar. The biggest difference is that a sine curve starts at 0, 0. A sine curve always starts there. So that's how you know that's a sine curve. And it ends like one full cycle, like we were talking about before, ends at 0. So starts at 0, ends at 0. And then a cosine, in this case it's 1. It's not always 1, but it's starting at 1, ending at 1. It's almost like it's a U shape, right? So that's the difference between the two. The next section wants to know the domain and range of the sine and cosine functions. All right, so let's start with the domain for the cosine. The domain on both of these, I think, are pretty straightforward. Now, remember that domain are the x values. So if I look at these graphs from left to right, even though I'm stopping at negative 2 pi and 2 pi, there's nothing to indicate that the graph would actually stop there. And if you were to graph these on your calculator, you would see that it would fill up the whole screen. So the domain for the cosine is negative infinity to infinity. And I would say the same exact thing for the sine function, right? There's nothing indicating it's going to stop, so it will go on in either direction. Now, the range. The range, if we're looking at the cosine, the purple one, going from bottom to top, do you agree that the lowest point is negative 1? Here and here, they're negative 1, but anywhere on the graph, it's not going to go lower, and it includes the negative 1. So I'm going to do a hard bracket, and the highest point is a 1. Now, don't you agree that it's the same for the sine, the pink? The lowest point anywhere on the graph is negative 1, includes it, and the highest point is 1. D, period. So this word is very important. It's a vocab word. It's going to pop up especially when we get to word problems here. Okay? So highlight it, star it, whatever. A period of a trigonometric function. Yeah, that was smooth. Trigonometric. After how much horizontal distance will both the sine and cosine repeat its basic pattern? So let's talk about the cosine. Okay, so what the period is basically saying is how long does it take for the cosine to complete one full cycle? I always like to start at 0. I feel like life is easy when you start at 0. So what I'm doing is I'm highlighting here. And when I get all the way back up to where I started, which is here, we talked about that being one full cycle, correct? So the question is, how long does it take for it to complete one full cycle? And the answer to that is 2 pi. Why is it 2 pi? Because if we start at 0, when we complete the full cycle, what are we above? We're above the 2 pi. Okay? Now, moving along the sine, I'm going to start at 0 again, and I'm going to trace this until I do one full cycle. So I've come back to where I started, right? But I haven't gone into the negative. So it's not one full cycle until it looks like that. So for the sine, it took me the same amount of time to complete one full cycle. Now the cycles aren't the same, right? Sine, I'm starting at 0, ending at 0, but it still takes me 2 pi. That's not always going to be the correct answer for because we're going to stretch these and shrink these, but for a standard graph like we just did, it takes 2 pi radians for each of those to complete one full cycle. All right, so on the next page, it says next we will see the effect of changing the coefficient A of the trigonometric function. We graph the function of the forms, basically the sine of x and the cosine of x. Exercise 2, the graph of cosine of x is shown below. So this is the graph that we just did. It's not as tall, so that tells me that if I were to label my x-axis, this would be a 1 right here, because that's as tall as it goes, which would make this a -1. So I'm just going to label the rest just for the sake of argument. Okay, now, it says to use the graphing calculator to sketch the following equations. Be sure the calculator is in radian mode, use zoom trig, and I'm going to show you that in a second. So if you see all these choices here, these are all the cosine of x, every single one. The difference is the number in front is changing, and so we're going to see what it does to the graph. When we did transformations a couple of units back, we didn't spend as much time on these types of transformations. We did a little eensy-weensy bit, but not as much. But here it's easier to do. So you are going to pull out your graphing calculator. Now, if you are not using the graphing calculator and you're using an app like the Calculate 84, you can. I was going to show it on that, but the Calculate 84 does not do something that's important. So if you are using that calculator, you may have to graph by hand. And I'll show you why in a minute. But so I'm going to type in, first of all, reset your memory if you need to. 3, the cosine of x. Now, if I do a regular graph, it looks, it looks like a cosine curve. Okay. Now, what is a little tricky here is if you notice where I am crossing the x-axis, it's crossing at some funky spots, some decimal spots. But when we graphed it, it was crossing in a very specific spot. And the reason for that is your x-axis here is going up to 10, right? But when we graphed it, we went up to 2 pi. So this is important and it's a very helpful feature. I'm going to hit zoom and I'm going to hit number 7, trig. By the way, number 6 is handy if you want to go back to a standard -10 by 10 window. All right, but I'm going to choose number 7. And notice the graph is looking different. And I am crossing, I apologize, it keeps trying to focus there, and I'm crossing at very specific spots, right? So it looks like those little tick marks are pi over 2, pi, 3 pi over 2, and so on, right? So it matches the same graph, all right? So I want you to take a minute and graph this on to the graph that you have now. So what I'm hoping you notice here is that it is still a cosine curve. It still is crossing the x-axis at the same spot. The difference is how tall it is, right? It's going up to 3 and down to -3. So that is basically the effect that 3 is having on the graph. So what I want you to do is to pause. You really got to pause and do this. Don't just wait for me to do it. And I want you to graph the other 3 graphs there and try to take a guess, or an educated guess on what this number in front is really doing to the graph. All right, notice on the next one it's upside down per se, meaning it's not going in the same direction. And what do you think? And that is correct. What do you think is causing that? You got it. Don't be afraid of the decimals. Halves are about as crazy as it gets, but it does happen. Isn't that so cool looking when it's all done? It kind of looks like some sort of sound wave. And well, believe it or not, that is kind of where they come from, which we will get into later on. So what is happening here with the A, the letter A in front, or the number in front of each thing? So if you notice on every single one of these, I think you will agree that they're crossing the x-axis in the same exact spot, right? That does not change on any of them. What has changed is the height of each one, right? Whatever that number was in front, that was how high it went. And if it was a negative, it started at the negative number. It kind of negated it. It flipped it upside down, right? Okay, so on the first page, we learned about the word period. And on this page, these vocab words that are important here are the height and the amplitude. They're closely related, easily confused between the two, but it does make a difference. The coefficient A controls the height that the cosine curve rises and falls above the x-axis. A's absolute value is called the amplitude. With sound waves, it indicates the volume, loudness of the sound. So what they're saying here, let me just pick a color that we have not used, just so it's not confusing. So what they're saying is, if I were to talk about, let's talk about the pink one, my height goes from the 4 all the way down to the -4. So on that one, my height is 8, technically, right? Because I'm going from 4 to -4, that's 8, right? If I were to count it, I'm counting 8. Now, the amplitude is basically that number in front. It's basically from the middle up. So if I'm talking about this pink one again, my amplitude is 4, which is what's right here. So my height is 8, but my amplitude is 4, okay? Let's take a look at the purple one. So because 3 is in front, that's my amplitude, right? From my x-axis up, I'm going 1, 2, 3. And then my height would be how tall it is from top to bottom. Well, if my top is here, my bottom is here, how far is that? Well, it's going to be double the amplitude. It's 6. But if I were to count that, 1, 2, 3, 4, 5, and I go all the way down to the 3. So it's 6. So the next part wants you to do this without the calculator. I don't know what you're going to do here. All right, you do it how you feel you need to do it. And then I want you to check back in. I want you to hit pause, and I really want you to do it on your own. Check back in to see what yours looks like compared to mine. Switch it up on you this time with some nice rainbow colors. Isn't that so pretty? I know, and then some of you are just gonna hand in your homework with just plain old pencil. But if you want some spice in your life, there you go. It's exciting as it's gonna get in algebra. Again, so you're using the sine curve, but again, the number in front is doing the same thing. It's deciding how tall it is. And if there's a negative in front, it's flipping it upside down. So I just want to talk about, let's talk about the orange one. What is my amplitude there? It's 3, right? It's how far I'm going from the middle. So then what is my height? My height is going from top to bottom. Well, how far is that? 1, 2, 3, 4, 5, 6, or double the amplitude.